Have you ever wondered which are the most important machines in the world of heavy construction? Not the most famous, not the most expensive, but the ones that, if they disappeared tomorrow, the entire modern world would simply stop being built. Because those machines exist, and most people have never heard of them. They do not appear in car commercials or technology headlines. They work in frozen tundra, at the bottom of oceans, and suspended hundreds of meters above river gorges. They are the reason you have roads under mountains, bridges over water, skyscrapers on solid bedrock, and cities connected by tunnels that run beneath the sea. Today, we are going to meet 5 of them. And by the end of this video, you will never look at the world around you the same way again. We start underground. Somewhere beneath a major city right now, one of the most remarkable machines ever built is moving through solid rock, slowly, quietly, and it will not stop until the job is done. Engineers call it a tunnel boring machine. Everyone else calls it the mega mole. And when you understand what it actually does, that nickname starts to feel like an understatement. The cutting face of a large TBM can measure over 17 meters across, wider than a 6-lane motorway. Behind it, stretching back over 120 meters, is an entire underground operation. Conveyor belts carrying away the broken rock, hydraulic arms feeding in concrete wall segments, navigation computers correcting the course millimeter by millimeter. All of it running together, 24 hours a day, while the machine slowly eats forward through the earth. But here is the part that genuinely stops people when they hear it. A TBM does not just dig. As it moves forward, it builds the tunnel walls behind it at the same time. Precast concrete rings are locked into position by hydraulic arms as the machine advances. It is destroying the earth in front of it and finishing the tunnel behind it, simultaneously, without ever stopping. The world's largest, built by German firm Herrenknecht, weighs nearly 5,000 tons and bores up to 30 meters of completed tunnel every single day. It has drilled beneath oceans, through earthquake zones, and directly under the foundations of centuries-old cathedrals without so much as cracking a stone above. Every metro line running under every major city on Earth. Every road tunnel carved through a mountain. The megamole was there first. From underground, we moved to the sky. But lifting things is only half the problem. There is a moment on every mega construction site that project engineers dread. The moment when something needs to go somewhere it has absolutely no business being. A nuclear reactor module. The legs of an offshore wind installation vessel. A refinery column the height of a 10-story building. That is the moment they call for the Liebherr LR 13,000, the most powerful crawler crane on the planet. This machine can lift 3,000 metric tons. To put that in your head, it can hoist 2,000 family cars off the ground at the same time, at a height taller than the Eiffel Tower. It rolls on crawler tracks, so it can carry a load across an active construction site without putting it down. Its main boom reaches 120 meters into the sky, and with a luffing jib attached, it goes even higher. 2 8-cylinder turbocharged diesel engines push over 1,300 horsepower through the whole system. And here is the engineering detail that gets people every time. Every single component of this crane is built to fit inside a standard shipping container. The most powerful lifting machine on Earth can be completely taken apart, loaded onto a cargo ship, sent to any construction site anywhere in the world, and put back together in days. It has set nuclear reactor modules down with millimeter precision. It has lifted the jack-up legs of the largest offshore wind vessels afloat. When every other machine on site has run out of answers, the LR 13,000 is the call you make. But before anything can be lifted, the ground beneath it has to be prepared. And that is a job that needs its own kind of machine entirely. The Ultraclass hydraulic excavator, machines like the Komatsu PC 9000 and the Liebherr R 9800, are not the excavators you see at roadworks. These things are in a completely different category. Close to 900 tons, over 10 meters tall, a bucket arm that reaches 19 meters across. And every single scoop lifts 80 tons of rock and earth and drops it in one fluid motion. At full production, one of these machines moves over 8,000 tons of material every hour, not per shift, every hour. They have carved the bedrock channels for the world's greatest dams, excavated the harbor floors where supertankers dock, torn through frozen ground in the Canadian oil sands at -40 degrees, and kept going. The modern world is built on foundations these machines dug, and every one of those foundations is only as deep, only as solid, and only as reliable as the machine that carved it out. Now we come to the machine most people have genuinely never heard of, and the one responsible for building more bridges than anything else on the planet. Picture this. You are standing on a bridge pier, hundreds of meters above a river gorge. There is no ground below you to put a crane on, no scaffolding anywhere near tall enough. The next pier is 50 meters away, and between the two of you is open air. You need to build a bridge. How do you do it? You call for a bridge launching gantry. This is a colossal overhead crane that travels along the bridge as it builds it, span by span, high above the ground. It reaches back, grabs a precast concrete segment weighing hundreds of tons, carries it forward, and locks it into position mid-air with hydraulic precision. Then it moves to the next one. The gantry advances. The bridge grows outward through the sky, and not one person on the ground below needs to do a thing. Without this machine, China's 45,000-kilometer high-speed rail network, the largest ever built in human history, would not exist. Every sea-crossing bridge, every elevated highway cutting through a mountain range, all built piece by piece in the air by a machine most of the world has never thought to ask about. And finally, we go somewhere almost no machine can follow. Beneath every offshore oil platform, every wind turbine standing in the open sea, every bridge pylon rising from a riverbed, there is steel. Enormous foundation piles, driven deep into the seabed, holding everything up against the full force of tide, current, and storm. The machine that puts them there is the Menck MHU-3500S hydraulic impact hammer. The industry calls it the gentle giant. It stands 21 meters tall and weighs 580 tons. Every time it fires, it delivers 3,500 kilojoules of impact force straight down through the top of a steel pile. That is enough to drive structural steel through solid rock on the floor of the ocean. It operates at water depths of up to 3,000 meters. Its deepest recorded job was at 2,250 meters below the surface, in total darkness, at pressures that would flatten a car like a tin can. And it does all of this more quietly than any comparable machine in the world, engineered specifically to protect marine life while it reshapes the ocean floor. Invisible, unreachable, holding everything up from below. 5 machines. The mega mole carving the underground. The crawler crane lifting the impossible. The excavator tearing open the earth. The gantry building bridges from the sky. And the hammer anchoring civilization into the ocean floor. You will never see them trending online. You will never hear their names in everyday conversation. But the next time you stand in a city, cross a bridge, or ride underground, look around. Every single thing you can see exists because of what these machines did first. They did not just build the modern world, they made it possible. If this video made you see the world differently, hit the like button and subscribe. Every week we go deeper into the machines and the engineering behind everything most people take for granted. Drop a comment telling me which of these 5 surprised you the most. I will see you in the next one.